Hello, Earth Science class. This is your Chapter 23 notes. The first section, the 23A section that we're talking about here is on the solar system, and that's what we're going to discuss today. So by definitions, a solar system would be anything like the sun and any objects that the sun holds by gravity around it. So that would mean the planets. That would mean all of the things located in the Kuiper belt, the New Horizons. So these are things that we can view, and because they're close in proximity to us. I want to point out some important words here. The first word, geocentric. Geo means Earth. So Earth-centered theory. This was an ancient model of the universe where the Earth was believed to be at the center of the universe, that everything revolved around the Earth. All the stars, the sun, the moon. The geocentric theory would have believed that planets had circular orbits, and there were some problems with that. So when people could look in the night sky through telescopes, they recognized that there were times where a planet would appear brighter and other times where they would appear dimmer. There were also some planets that would exhibit what we call retrograde motion. Retrograde motion is an optical illusion. It's kind of like this. If you are sitting at a stoplight, your car is sitting still, and you look out the window next to you, and there's a vehicle pulling up very slowly next to you at the stoplight, you have the feeling that you're moving. You're not, because you're sitting still. Your foot is on the brake. But because the car next to you is moving, it has a feeling to you that you're moving, right? That's like an optical illusion. Retrograde motion was something that when we observe different planets in the night sky, for example Mars, there are times where it appears like it moves backwards and then it moves forwards again. It does not really change its path of motion. It's still moving forward as it is always, but because of the size of its orbit compared to our orbit, it makes it feel like Mars moves backwards and then forward again. Okay, so these problems that astronomers observed helped them to realize there was something, there had to be a different way to explain the solar system. But there were some pushback here. There was a guy by the name of Ptolemy who had a different way of explaining things. He gave the term epicycles to be like curlicue cycles. He thought, and this was a way to explain this idea of retrograde motion. Okay? This was also a very strong pushback, was the fact that the Roman Catholic Church upheld the idea of a geocentric theory. And not only did they uphold that, they actually made it illegal for you to teach anything differently. So people who viewed the Earth and viewed things through telescopes were not able to teach that legally to others. Okay? There were some gentlemen, though, that came along and said, no, we refuse to be held back by the Roman Catholic Church and any opinions that scientists had in the past. We are going to use the proof that we observe in math to prove the heliocentric or sun-centered theory. So Nicholas Copernicus wrote a book called The Revolutions, and he was one of the main scientist who is bravely putting his life on the line by teaching the fact that the sun was the center of the universe and not the earth, that the moon orbited the earth, but the rest of the planets and the sun did not. So the heliocentric theory was challenged by many. It began the time frame known as the Copernican Revolution, where mankind began to be proven otherwise for their theories. Another guy by the name of Tycho Brahe came along. He was known as the most accurate astronomer of his time. Along with Galileo and his new telescope, they critiqued that geocentric theory and talked about why it could not be true, and they changed the mindset into what we have today known as the heliocentric theory. Kepler, a brilliant mathematician, also observed planets' orbits and discovered that they were not circular, but instead elliptical, oval. Okay? Oval has two foci instead of one foci. Foci would be center points. Okay? There were also 3 laws of planetary motion that Kepler came up with. These laws of planetary motion, number 1 was planets move in ellipses with the sun as one of its foci. His second law of planetary motion said that a planet moves faster when it's closer to the sun and slower when it's farther away from the sun. So it's not always the same time frame for motion. His third law of planetary motion said time that planets take to orbit the sun and their average distances from the sun have always had the same mathematical relationship. You could pick 2 points on a pathway, an orbit around the sun, and add them up, and they will equal 2 other points. Okay, there are 2 other terms here, perihelion and aphelion, the point at which a planet is closest and farthest from the sun. Sir Isaac Newton also was a mathematician, and he described gravitational force on objects in the solar system. And that concludes our 23A notes.